In this lecture, I am going to show you that we can actually use already built third-party coroutine types and bypass the need to build our own coroutine types. From the last lecture, you know that we had to build our own coroutine type, which is a generator that we can use in this way. It generates numbers on the fly, and this was really cool. But building your own coroutine types is not a trivial task, and getting this right may require a lot of experience. So my prediction is that most C++ developers are going to use coroutine types that have been built by other people, and this is a good skill to master because it's going to save you time. In this lecture, we're going to see a bunch of third-party libraries that provide coroutine types. And the first one you're probably going to be recommended is CppCoro, because this is a reference implementation of the coroutine specification in C++. It was designed by Lewis Becker, who is one of the designers of the coroutines that we have in C++20, but this library is not easy to build. So I am going to bypass it, and I am going to use something that provide header-only implementations for the coroutine types so that we can use them directly in our code. So to use these third-party libraries, you will need to include them somehow. So you may put in an include statement like this. And once you do this, you will need to change your generator to use the third-party generator that you are using in your code. So for example, we are going to use something called unique generator. So we're going to change our return types to use this thing here. And we're going to be changing all our coroutine functions to use this thing. Now, once we do this, we will need to change our code to work according to this unique generator thing, because it may not provide the interface we need to use it as we used our own custom generator we did in the last lecture. And I am going to show you these differences once we hit Visual Studio Code in a minute. Okay, so here I am at GitHub, and this is a repository for the CppCoro library. If you go to the top, you're going to see that this is a library of C++ coroutine abstractions for the coroutine technical specification. So this is really a reference implementation. It was done by Lewis Becker, and it is really good. It has a lot of coroutine types. You see that we even have a generator like ours. If we look at it, we will see that this is a generator representing a coroutine type that produces a sequence of values of type T, where values are produced lazily and synchronously. So you can use it, for example, like this, and this is going to do whatever you want. And you probably understand this code because we have set up something like this in the last lecture. So if you go back, you're going to find that we have a bunch of other coroutine types. You can check them out if you want, but most of these are not going to be very understandable because they really work in a synchronous code where you have things happening independently. And we are not going to touch on that in this lecture because that's a little bit advanced. One problem I have with this library, as I have said, is that it is a little bit complicated to build. So I didn't really want to go through the complex steps to build this library on Windows, Mac, and Linux because some of you are going to be watching this course on different platforms. So that's a really bad approach. It is going to confuse many students who just want to use these coroutine types. You aren't really interested in how to build these libraries. So what I am going to do instead is use a header-only implementation of these coroutine types. And we have a bunch of these in this repository called Coro. And if you go down, you're going to find a bunch of coroutine types they have. For example, we have a bunch of generators. And the generator I chose to use is unique generator. Let's see if I can find it. And now that I am looking for it, I'm probably not going to find it. Okay, let's go in our include directory. And if we go down, we will find unique generator. This is the generator we want to use in our C++ project. If we zoom in on this, we're going to find that it really has everything we have seen before. You see that it is going to have a bunch of methods that are required in our promise types. Let's go down and see if I can show you that. We have get return object, we have initial suspend, we have final suspend, we have yield value. You see that you recognize these methods, but one of the things we don't have is the function call operator on this coroutine type. And if we try to use that, we will be in trouble. And that's why it is really good practice to read the documentation for the coroutine types that you are trying to use. Some repositories are going to find a bunch of examples, and it is a good place to look to see how you can use your coroutine types. So let's go down and see if we have an example for a unique generator. Let's look at generate ints here and see how it works. And we will see that this is going to use unique generator. We will return unique generator, and we are going to generate numbers. You see that we are going to loop around and co-yield. And to use this, you will see that they have a range-based for loop. And this range-based for loop is working because we have iterators implemented in our unique generator. Let's go back and see if we can open this up. Let's go up again and find our include directory. We're going to look at unique generator here, and we will see that it has an iterator class embedded in our coroutine type. Let's go down and show you that because it is crucial to see. And this is going to give us a hint that we can even use begin and end iterators to loop through numbers generated from our generator here. And this is really cool. So you see we have our iterator class. It is going to define how we can loop through things we generate through this generator and use begin and end iterators. You see we have a begin method, we have an end method. The begin method is going to resume the coroutine and return whatever value is pointed to by the iterator, and we will be able to use it in our C++ program. So I think we have talked about this a lot. It is time to head over to Visual Studio Code and actually play with us. So here we are in our working folder. The current project is third-party coroutine types. I think we are going to reuse the code from the last lecture and adapt that a little bit. So let's do that. We're going to copy everything from there, and we're going to crack this open in Visual Studio Code. Let's do this. And what we want is to remove our custom coroutine type because we are going to use a third-party implementation of these coroutines. We can take this out. And what we will do is grab the code for unique generator here, and we will create a file and put in this code. You can download this and include this in your project, but I think it is just easier to copy everything and paste this in a file that we create in our Visual Studio Code project. Let's copy everything here, and I will go in my project here and create a new file. I am going to call this unique generator.h, and I will paste in my code, and you will see that this is exactly what we had on GitHub. Make sure you provide the original source for this because that's going to be really good for everybody who looks at your code to know the source. And once we have this, we will include this in our main function, or main file I should say. So we're going to do that, unique generator, and we will change our coroutines to use unique generator. Let's do this. We're going to say unique generator. And I think I can copy this and paste this in every place where we need it. So unique generator and unique generator. And now if we try to use this like we have used it before, we will see that things are going to blow up in our face. Let's make sure we comment out the range implementation here because I don't want to try this out first. We will try the simplest. So we're going to grab the one that uses our generate numbers function. And you see that we have a bunch of squiggly lines on task 1 here when we try to call our function call operator. And we will have this problem because we don't have a function call operator in our unique generator type here. So if we go in, we will see that we have no member named mhandle. So this is the first problem. But even if we take out this line here, we will see that our code is not going to compile. So let's pass this through GCC. And we will have the same problems, and we will see that we don't have a function call operator here, and this is the problem. Now, if we have this kind of problem, we probably are using our generator in a bad way, and a good thing to look at is the documentation or the examples, and you see that we have to go through begin and end iterators to be able to loop through the data that we have in our generator. So what we can do, for example, is say, we want to loop through this using a loop by using begin and end iterators. So we can say something like this. We can say for auto I equals begin or task1 begin, and we will grab our beginning iterator, and we want to loop as long as I is different from the end iterator. So we're going to say task1 and end, and we will increment our I iterator. So let's do this. And as we loop through this, we will dereference the iterator and print the value. So we're going to say value, for example, and we will dereference the I iterator and print the value. Let's see how this works out. Because we already know about iterators, so we should use them in this way. And let's make sure we understand what is going on here. I different than task1, and I think this is good. Let's pass this through the compiler and see if we have no compiler error. The build is good, so we can bring up a terminal window. And if we run this, we will see that it is going to print our values. We have a value 10, we have 20, we have 30, and we are going to hit the end of the coroutine. And this is going to print all the values that we generate as part of the loop we have here. This is one way we can use our coroutine here. But if we still want to be able to use the function call operator, we can still go through our coroutine type and implement that. Let's find our unique generator class. You see it right here on line 94 in our implementation. Okay, so let's go all the way to the bottom after our iterator. So we're going to find the end of this, and we will go before the point where we have our private section here, and I am going to put in our function call operator. So I am going to say auto, I am going to deduce the return type, I will say operator function call, and inside I am going to resume the coroutine and return the current value. I am going to go through the promise and call the get method, and I know I should call the get method because if I go in my promise, I am going to find a get method which is going to return a reference to the current value. So you kind of have to dig through the code to understand how you can use this. Now that we have our function call operator, we can really use our coroutine like we used our custom coroutine. And this is something you can do. I just wanted you to know this. So we can actually take out the for loop here. And for example, say stdc out and say value 1. Or value, this is going to do, and say task1 and call the function call operator, and this is going to pause on the first call yield statement in our coroutine here, and it is going to print 10 because this is the value we just yielded in our coroutine here. So let's see what we get if we run this. We will pass this through the compiler. So the build is good, we can clear and run Rooster. We will see our value printed out, and everything is working as we expect. This is even going to work for our infinite number stream. So let's make sure we uncomment this because we have our function call operator. If we loop around, we're going to see that we will print numbers indefinitely. We can pass this through the compiler and run Rooster, and we will see that we will print numbers indefinitely, just like we did from the last lecture, and this is really cool. Let's use the range version of our coroutine. We can comment this out and use our range. And if we uncomment this and pass this through the compiler, hopefully this is going to work just fine. The build is good, we can clear and run Rooster, and our code is going to work exactly like it did before, and this is really cool. If you want, you can even use this like we are using this in our example here. For example, we can use a range-based for loop, and this is going to work really well. So, for example, instead of using a loop like this, we can use a range-based for loop. So, let's say for auto, I in our task 3, because this is going to give us a range, and we will print out the value. We will say stdc out, say value, and we will put out I or V. Let's call this V, and we will say that this is V, it's not 1. And if we build and run, we will see that this is going to work just fine. And the range-based for loop is working here because we have a bunch of begin and end iterators in our coroutine type. If you go here, you see we have our iterator class, and after it, we will have a begin method and an AND method, and these are what the range-based for loop is going to look for to work here. So this is going to work just fine. Let's pass this through the compiler. The build is going to be good. We can clear properly and run Rooster, and we will see that this is going to work just fine. This is really what I wanted you to see. It is possible to use third-party libraries and avoid the hard work of building your own coroutine types, and make sure you use this to your advantage because it is going to save you a lot of time. I have said on occasion that I actually don't even recommend building your own coroutine types unless you really know what you are doing. If you are a beginner at this, or if you still have some confusion, you are probably going to put yourself in trouble by building your own coroutine types. So even if you decide to build your own, it is a good idea to come to this implementations and look at how they did the job, and you probably will learn new things or new ways you can build your own coroutine types, and that's going to be a good reference. This is really all I had to share in this lecture. I hope you found it interesting. We are going to stop here in this one. In the next one, we are going to try and recap what we saw in this chapter. Go ahead and finish up here and meet me there.